Welcome to STEM Professionals. In this video, we'll discuss three important topics. The first one is position. The next one is distance. And finally, the topic is displacement. So let's start with the video. So as of now, we have completed with the first chapter, that is Introduction to Physics. Now we'll start with the second chapter, which is one-dimensional kinematics. Now this chapter comes under the branch of physics which we call mechanics. And mechanics is the area of mathematics and physics concerned with the relationships between force, matter and motion amongst the physical objects. Now in this chapter, we'll discuss the terms like position, velocity, acceleration, equations of motion and many more things. But as of now in this video, our main focus would be on the terms like position, then distance and displacement. Now in physics, the terms like position, distance, displacement have specific meaning, and we'll discuss the definition of these terms and how they are used to describe the motion of a particle. Now at the end of this video, you will be able to give the answer for these two questions, this one and this one, comfortably, but at the end of this video. So let's start with the first topic, that is position. Now the first step in describing the motion of a particle is to set up a coordinate system that define the location of the particle, or what we call the position of a particle. Now the coordinate system in one dimension is shown in this image. So this is a coordinate system. Now coordinate system is simply an x-axis with the origin, and this is our origin where x equals to 0. Now in setting up a coordinate system, we are free to choose the origin. So we have taken this as our origin and we are free to choose the positive direction. So this direction we are taking it to be positive. Now one thing you should keep in mind, that once we define the origin and the direction, we must be consistent with that throughout the calculations. So this thing we have taken as our origin, and this is the initial position of the person or the particle. So we can write this is xi. This is the initial position. Now here this is the final position of the particle or the person in this case. Now because we have taken our positive direction in the right side, so we can say that the final position xf, this value should be greater than the initial value xi. So this is the initial position and this is the final position. So this is all with the position. Now next we're going to discuss the term distance. Now to understand distance, we're going to use this animation. Now in this animation we can see that cartoon character started running from the initial position and it stopped at the final position. So the distance traveled would be equals to the total length of the trip. Now let me show this with this figure. So this was the point where the cartoon character started. So this is the initial position xi, and this is the point where it stopped. So this would be the final position xf. Now the distance traveled would be the length of this trip, which is 12 meter. So in this case, the distance would be equals to 12. Now some important things that we should note about the distance. The first one, that distance is always positive. It cannot be negative. So distance is always positive. Now it is a scalar quantity because no direction is associated with distance. So it is a scalar quantity. Now we can see the practical application of this term distance. Like in our car, The distance traveled is indicated by the odometer that you can see in the car. Now next we're going to discuss the displacement. Now let us define displacement. Now displacement is basically the change in position. Now let us understand it with this animation. Now this cartoon character started from the initial position, then backward, and it stopped at the final position. So the displacement would be equals to, let me write here, it will be equals to the change in position, that is the final position minus the initial position. Now in physics we generally write this change in position to be as delta x, which is xf minus xi. Generally for a change we'll represent it with delta. So this is what we defined as displacement. Now let me consider this figure. So this is the point where the cartoon character started. So this would be the initial position, that is xi, and then it goes like this and then backward, and it stopped at this position. So this is xf, the final position. So the displacement in this case would be equals to the change in position, that is xf minus xi. So xf we have this point which is 0. This is origin, so this is 0, minus xi we have this point, this is 4, so 4. That would be equals to minus 4. So in this case the displacement would be minus 4. Now if you see the distance, suppose in this case we need to find the distance. So distance is basically the total length that the particle have traveled. So first it traveled from this to this, that is 12 meter. Then again from this point to this point, so again 12 meter. And then from this point to this point, that is this is 4 meter, so this is 4. So that would be equals to 28 meter. So the distance would be 28 meter, but the displacement will be minus 4. So this is important. Now you can compare the difference between the distance and displacement. Now last I'm going to write the summary. That is, so this is the summary, that position and displacement are measured relative to a coordinate system. The coordinate system must include an origin and a positive direction that we have shown here. This is our this side is positive and this is origin. Now the displacement has a direction and a magnitude, hence it is a vector. So displacement is a vector quantity. Now distance has only numerical value and hence it is a scalar. So this will be the summary. Now let's get back to the question that I introduced in the starting of the video. So this was a question. This is the part A, part B. Now we need to explain the first part, that is it possible to take a trip in which the distance covered is less than the magnitude of the displacement. Now we know that distance is always positive, it cannot be negative, and it's a scalar quantity. Now displacement can be positive, can also be negative depending on the direction. So the distance cannot be less than the displacement. So this statement will be wrong. No, it is not possible. Second statement says that is it possible to take a trip in which distance covered is greater than the magnitude of the displacement? Yes, it is possible, as you can see in this example only, that in this case the distance was 28 meters, and if you see the magnitude of displacement, it was 4. The magnitude was 4, which is which is less than the distance. So yeah, it is possible that distance can have a greater value than the magnitude of displacement. So this is true. This is, we can say yes, it is true, and this is wrong. So I hope you are done with this concept. So this is all with this video, and in the next video we'll discuss about the average speed, average velocity, and so on. So thank you.